Assalamualaikum and good day to everyone. So in this session we're going to continue with free vibration of dam system under the topic of single degree of freedom system. So for free vibration of dam system, we know that the equation of motion is mx double dot plus cx dot plus kx is equals to 0, whereby the c is actually the damping coefficient or damping constant. So, if let's say this is the equation of motion for free vibration dam system, and if I divide everything with m, okay, divide with the mass, I will get the equation will become x double dot plus c over m x dot plus k over mx is equals to 0, where this c over m can be written as 2 zeta omega n, while k over m is omega n squared. So the previous equation, which is this one, will become this. So this zeta is what we call as damping ratio, whereby damping ratio can be written as c over cc, where c is the damping coefficient and cc is the critical damping coefficient, in which can be written as 2 omega n multiplied with mass. And we know that omega n squared is actually k over m. So basically, from free vibration of dam system, the solution can be written in many terms, such as you can see here, in which all of these will give you the same answer. But again, if you refer back to the second last page of your lecture notes, we will just focus on this equation which represents the free vibration of dam system response. Okay, as I mentioned earlier, you can use this, you can use this, this and this. All of this will give you the same answer, but to me, I think the easiest way is we just use this equation instead. And for free vibration of dam system, there are 3 different cases. Okay, for free vibration dam system, there are 3 cases whereby we have under dam system where zeta is less than 1. So how do we want to know whether it's under dam system or not? Zeta is less than 1. We know that zeta is c over cc. So if zeta is less than 1, therefore c is less than cc, or the damping coefficient value is less than the critical damping coefficient, and so on. Okay, that is case number 1 for under dam system. We also have critically damped system, whereby zeta is equals to 1 for critically damped, or c is equals to cc, because we know that zeta is c over cc. Therefore, if zeta is equals to 1, therefore c is equals to cc. That is the case for critically damped system. And for overdamped system, zeta is larger than 1, or c is larger than cc, meaning that the damping coefficient is higher than the critical damping coefficient value. And if you can see here in this equation or this response, okay, we need to identify the omega d, or the damping frequency. Damping frequency is given by omega d is equals to omega n square root 1 minus zeta squared. Okay, so you can refer the equation in page 45. Alright, so let's look at the response between underdamped, critically damped and overdamped system. So if you look at the response for underdamped system, meaning that the damping effect is not that large. So you can see that for underdamped system, okay, you can see that from time to time the vibration will dies out. Okay, but for critically damped, okay, the name suggests that the damping effect is high. So you can see that it doesn't oscillate, okay, it just dies out, right? And if we look at overdamped system, okay, overdamped system takes longer time to dies out, and same critically damped and overdamped, both of it doesn't oscillate. It's just that for it to dies out, it takes quite longer time for overdamped compared to critically damped. And if we compare between undamped, underdamped, overdamped and critically damped, so if I want to grade it, okay, undamped meaning that it doesn't have any damping effect. Underdamped means that there is a damping effect, but it is very small. Overdamped, it takes longer time to dies out. Okay, so this is the response for overdamped. Okay, so if I trace it with blue, and the highest effect is critically damped. You can see that critically damped and overdamped, both of it doesn't oscillate as compared to undamped and underdamped, but it takes shorter time to dies out rather than overdamped. Okay, so these are the comparison between undamped, underdamped, overdamped and critically damped. Alright, so now again, what we need to solve in the end is that we need to find the A1 and A2 and all the unknowns from the response, because the important thing is that we need to use the equation for, or the response equation that you can get or obtain from last 2 pages of the slide. So for free damped vibration, okay, the response can be written as xt is equals to E negative zeta omega nt multiply with A1 cos omega dt plus A2 sin omega dt. Okay, so same things. Okay, what we need to do is that we need to apply initial condition to find all of the unknowns. Okay, but it is not as simple as free undamped vibration, in which for us to find the x dot t, we need to use product rule. Okay, because we cannot simply differentiate it without using product rule, because it involves multiplication between this and this expression. So if you refer back to your notes on differential equation, so to use product rule, okay, for those who don't have strong fundamental in maths, please try to do a bit of revision on product rule. Okay, so we can write it as UV. Okay, so to use product rule, U is equals to E negative zeta omega n t, and U prime is negative zeta omega n e to the power of negative zeta omega n t, because product rule is uv prime plus vu prime. So in order for us to find x dot, we need to use product rule, which is uv prime plus vu prime, and v is this part. So v is a1 cos omega dt plus a2 sin omega dt, and v prime is the differentiation of this. So we get negative omega d a1 sin omega dt plus omega d a2 cos omega dt. So to find x dot t, which is uv prime plus vu prime, so just write back u is negative zeta omega nt multiply with v prime, which is negative omega d a1 sin omega dt plus omega d a2 cos omega dt. Okay, plus vu prime. So v is this one, so a1 cos omega dt plus a2 sin omega dt multiply with u prime. So this is u prime multiply with negative zeta omega n e to the power of negative zeta omega n t. Okay, so now we have already obtained what is the equation for xt and x dot t, because next is we're going to use initial condition to find all the unknowns in here. So when we consider initial condition, so what is initial condition? X when t is equal to 0, we can write it as x naught, and x dot t equals to 0 is equals to x dot naught. So we replace x naught in this equation. Okay, so I copy back. So when t is equals to 0, so e to the power of a 0 will become 1. Okay, cos 0 is 1, sin 0, because t is equals to 0. Okay, so sin 0, everything will become 0. So therefore x naught, which is x when times is equals to 0, is equals to a1, or because we're trying to find a1 here, so meaning that a1 is x naught. Okay, so now we have already obtained a1. Next we need to find a2. So to find a2 is This is the equation that we need to use. Okay, so we replace. So for x dot naught, or t equals to 0, so we replace this with 0. So e to the power of 0 will become 1. Okay, sine 0, so meaning that all of these will become 0 because sine 0 is 0. Cos 0 will become 1. So meaning that in here we will have only omega dA2 multiplied with 1 plus A1 cos 0. So everything will become 1. Sine 0 will become 0. So meaning that all of these will become 0. 0 multiply, and then this will become 0. So e to the power of 0 is 1, and we only left out with this. Okay, so if I write this, okay, this is just mathematics. Okay, very simple. So x dot naught, because x when time is 0, is equals to 1, which is this one, multiply with 0 plus omega dA2. Okay, plus A1 multiply with 1, so A1 plus 0, because all of this has become 0, multiply with negative zeta omega n. Okay, so try to do it yourself and you get and so that you can try to get the same answer. Okay, so again, this is just mathematics. So x dot naught is equals to omega d a2 plus negative, plus and minus will become negative, so negative zeta omega n a1. And we have already know that a1 is x naught. Okay, a1 is x naught, and what we're trying to find is this a2. So omega d a2 is x dot naught plus zeta omega n x naught. So a2 is equals to x dot naught plus zeta over omega n divided by omega d. Okay, so now we have already determined what is a1 and a2. Okay, and then we place back in this original equation for free damped vibration system. Okay, replace a1 and a2 in here. So the equation will become a1 is x naught and a2 is x dot naught plus zeta omega n x naught over omega d. Okay, so try on your own and check whether you can get the same answer or not. Okay, omega n you can get from square root k over m. Zeta is c over cc. Omega d, okay, so if you refer back to the equation, so omega d is equals to omega n square root 1 minus zeta square. Okay, so you can find whatever displacement value once you got all of these unknown. Right, try to do it yourself, and that's all. Thank you very much.